Hi everyone, my name is Harini. So, before we dive into HTML, CSS, JavaScript, and everything else we have learned this semester, I just want to take a step back and ask a very simple question to start with. Have you ever wondered what actually happens when you open a website? Whether you're ordering food, like watching Netflix, booking a flight, or even attending, let's say, this online class, the same process happens behind the scenes. So once we understand this process, every topic that we have learned in this course starts to make sense. Like a peek into the history, the www was invented by Tim Berners-Lee in 1989 with one main goal: just to help the researchers share information much more easily across computers. At first, the picture of a website was just like a simple documents containing text and images. Today, the websites have evolved into more powerful applications that allow us to, shop online, chat with friends, manage bank accounts, and even collaborate with people across the world. Although websites have become much more advanced, the basic communication process has almost remained the same. So, let's understand this process with something everyone can relate to. Let's say ordering a pizza online. Imagine you're hungry. You're just opening the Domino's website. You choose your pizza. You click place order. Now your pizza doesn't magically appear on your screen. Of course not. Instead, here's what happens. Your browser sends a request, and in web development, this browser is what we call as a client. And think of the client like a customer placing an order. So that request travels across the internet to the restaurant, and in web dev, this restaurant is what we call as the server. Now the server receives your request, prepares what you asked for, and sends back a response. This response travels back to your browser, and your browser displays it. Instead of a pizza, it's usually a web page, some data, and maybe your account information. But how does the client and server know how to communicate? Just like people, even computers have a language. They have a set of rules. Now these rules are what we call as HTTP protocol. So what does it stand for? Hypertext transfer protocol. HTTP simply defines how a client sends a request and how a server sends back a response. So now that we understand how websites communicate, the next question becomes, what exactly is the server sending back? That's where HTML, CSS, and JavaScript comes into the picture. Together, these three main technologies form the basic foundation of every modern website, and that's exactly where we are going to begin. Now, if I order a pizza online right now, how does it my la- how does my laptop right now communicate with the restaurant that's miles away in just like few seconds? Now, the answer to this one question is the entire story of this web development. So, when the server sends the response back to your browser, what is actually inside it? Like, what is a browser receiving and turning into a page? Like, what you see, what you scroll, what you click on? The answer is the main three things: HTML, CSS, JavaScript. Every single website you have ever opened, whether it is Netflix, your bank, your class portal, it's these same three technologies underneath. So, all the frameworks that you see today are built upon these. So, let me open the box and show you what each one does. Now, I'm gonna keep this physical so it sticks. Think of building a house, and the HTML is the structure, the walls and the rooms and the skeleton. CSS is everything you see: the paint, furniture, the way it looks and feels. JavaScript is the electricity and plumbing, the stuff that makes the house actually do what something you flip a switch. Uh, Structure, style, behavior. That's it. So let's start with HTML, the structure basically. So HTML is not really a programming language, it's a markup language. Its whole job is to describe what is on the page, how it looks like, just what it is. So this is a heading. Let's say, like, yeah, this is a heading, this is a paragraph, this is an image, this is a form. You write it using elements, and elements is just an opening tag, some content, and then a closing tag. Instead, that opening tab you can I mean inside that opening tag you can just add attributes, which are basically name and a value that gives the browser some extra information. Now here is where I actually want to show you what I really care about. There are few rules that separate someone who just writes HTML from someone who writes good HTML. First is the semantic tags. uh Instead of throwing everything into the div, You use tags that mean something. Okay, let's say the header, the nav, main. We have section, we have article, footer. What does that? Why does that matter? Because a page is not just read by people anymore. Okay, and that takes me into the single most important rule. And if you want, you can write it down. Every page should have exactly one H1, just one. The H1 is the title of the page. It does three main job at the same time. One, it tells a sighted user what the page is about. Two, if someone is blind, they use a screen reader, and that H1 is what announces what the page is. Three, when the Google or an LLM scraps your page, your H1 is what they use to understand it and list it. There are actually people right now in today's time doing prompt injection on their own H1s to game the search ranking and trick LLMs into ranking them first. This is how much weight this one tag carries. Just one tag. So you do not get to be lazy around this. Same idea falls for the images. Every image needs an alternative text, a short description of what the image shows. Because if a screen reader hits an image with no alt text, the user gets nothing. It's just an accessibility thing first, and an SEO thing second. SEO is basically search engine optimization. Now, uh, so every tag that opens has to close. These are just few additional things. Everything nests cleanly. One practical thing that confused me early on is that your main page has to be named after index.html, because this is the default file any server hands back when no specific file is requested. One more tiny thing that will save your time is that when you make a change, the page does not update. It is broken. The browser caches the old version. So you need to refresh it, hard refresh it. So HTML gives you the board. CSS gives you the look and feel. A CSS rule is very simple. You just have a selector that picks an element, and then a block of property and value. It's more like a map. This property and value pairs that style it. Color, spacing, fonts, layout, all of it are like an example set of examples that CSS has. So, and by the way, there are three ways to add CSS. First is the inline, and second is the internal in a style tag, third is the external in a separate file. In our class, we only use external, and honestly, that's a right habit, anyways, because it keeps your style separate from your structure. Now that a few things that actually matter once, not now, but like maybe in like going forward when you build bigger applications, these are few things that actually matter once your style sheet grows. So the first thing is the box model here. Now, every element on the page is a box, content in the middle, and then the padding around it, and then the border, and then the margin, like on the outside. So, by default, the width you set only applies to the content. So, the padding and the border gets added on the top. So, your box ends up being bigger than what you expect. Now, how do we fix this? Is by using the box sizing. So, you have to set the box sizing as border box, which makes the width include the padding and the border. And now you set it once for everything. So the second thing is like, how do you like let's say a exact one element has two types of styling on it. How do you decide which one wins? So this is what happens when two rules conflict. There are three concepts that decide the winner. Cascading, which means the latter rules override or earlier ones. Specificity, which means that the most specific selector wins. And then there is actually a score behind it. An inline style is worth 1,000, an ID is 100, a class is a 10, and a plain element is just one. Third is the inheritance, which means some properties like color and font, they flow on from parent to child. But things like width and margin, they don't. Now, the golden rule over here is that never use the exclamatory mark important tag. It overrides everything and just makes your CSS impossible to debug. Use it just to test something and then delete it. For layout, we have two tools. Flexbox for one-dimensional things, that is a single row or a single column, which is perfect for a nav bar. And then we have grid, which is for two-dimensional things, like let's say rows and columns together. These are two basic things, the old ways of of forcing layouts with tables. In class, right now we use Bootstrap. This is a CSS framework, like a framework that is built on CSS. So how Bootstrap works is it is built on a 12 column grid. You just say this block takes 8 columns, this one takes 4, and it handles the responsiveness for you. So all right, now HTML is a structure, CSS is a style. JavaScript is the behavior. This is what makes a page actually do something. You store the data in variables and you use const and let and never variable. So var is how we represent a variable. Variable is old and it leaks in ways that cause bugs. So your data comes in types, that is strings, numbers, booleans, and then there are two big ones. That is the arrays, which are ordered list in square brackets, and then the objects, which are bundles of like keys and values. Again, map structure. So they are surrounded by curly braces. So with arrays, you get these superpowers like map, filter, reduce. Map transforms every item. Filter keeps only the ones you want. Reduce boils the whole list down to a single value. So once it clicks, you just stop writing loops just by hand. Now, you can write functions three different ways. The classic function declaration, a function expression you store in a variable, and then the arrow function, which is the short modern syntax. Now, because a web constantly has to wait for things, data coming back from server, a file loading, JavaScript is asynchronous. You handle that with promises and async slash await. So your page never freezes while it waits for something. Now, here is a piece that connects JavaScript back to HTML and DOM. DOM is basically document object model. So DOM is your HTML represented as a live tree of objects. So JavaScript can reach into this DOM tree and change things. So what you have to do is you grab an element with something like let's say document.get element by ID. You listen for something that happens to this element by using by like tagging it with add event listener. So it keeps listening to events like a click or a form submission, and then you change the page. This is how the whole loop runs. Select, listen, update. Now, one specific thing that is easy to miss. So when you listen for a form submission, the browser by default has a default behavior just to reload the entire page. So you can stop that with prevent default so that you can update the just the part that changes instead of reloading everything. So this is literally the door into the concept that we call as Ajax. Okay. So as your code grows, you split it into modules using import and export. Now in this class, we only use ES modules, which is what we call as ESM. And you turn that on by just adding a type equal to module on a script tag. And again, on a side note, when you're unsure about a tag or a property or a method, you can check it out in MDN, the Mozilla Developer Network page. So it has most of it. It's a very nice documentation also. You should try it once. Updating the DOM by hand piece by piece every time something changes that does not scale once, your app gets big. So this is exactly why frameworks like React exist. They manage the page for you. And that little trick is just what I like mentioned, updating part of the page without a full reload. That is what we call as Ajax. And it is how your browser quietly talks to the server in the background, which is exactly what we're like where we're going next.
Hi guys, for the live coding session, I'm going to recreate the world's first web page written by Tim Berners-Lee in 1991. So I'm just going to recreate it by from scratch, like and show you. Let me show you it once, and show you how one style sheet can or like transform this 35-year-old page into something modern. So I'm not going to touch the HTML page at all. I'm just going to add another CSS page and show you the difference. So yeah, for now, let me show you how an inline style works. This is how you add the inline style. Thing about the inline style is you for each and every element you cannot reuse the same code, so that gets like redundant and it's a huge hassle. So instead we go for either internal or external. We go for mainly we prefer external to maintain the modularity of the code. So let's I have the style sheet, but I have to link it over here. So let me link it. Yeah. Now, let me start with body. We see that this entire one is misaligned. Too many changes are required here. So let me start with font family. And then I'll add a margin, 48 pixels, and I'll keep This auto. This is more like the horizontal, vertical orientation over here. I'm gonna add max width to this page so that the content is contained, and I'm going to let's see how it. Okay, it looks good. A little bit more padding, 0.20 pixel. Let me add color to this page. I have a custom color hexa code and also background and line height to space out. Uh, okay, looks good. It's just that the H1 is a little out of space, so I'll add color to that as well. I'll just make it green, and then border bottom. I'm going to make it 2 pixels solid border with a custom color that is, and then padding. Okay, there's an error. Yeah, looks somewhat good, but then the links are a little bit messy. I don't like these random blue color over the links, so I'm gonna remove that. I'm first gonna give them a color, and then I want to keep text decorations as none. Instead, I'm going to add a text decoration as underline when I hover over it, so that makes it a little bit more better. So yeah. So this is how you see an entire page has been transformed by just a few lines of code here, and you don't have to keep writing these set of code for like each and every element in that page. So you can just reuse it. So this is how we converted the page. Yeah.
Okay, so everything we talked about up to now, HTML, CSS, JavaScript, all of it has been running in one place, that is the browser, the client, the front end. And that is exactly what Project 1 was about. So, a two-tier app, just a browser talking to a static file server that hands back the files. Now we cross to the other side, that is a server. And on the server, two things run the show: Node and Express. So, coming to Node, Node is a runtime that lets you run JavaScript outside the browser. It runs directly on the server. That is the whole idea, and it's a big one, to be honest. The same language on both sides, front end and back end. It is built on the same V8 engine that powers Chrome, which is exactly what makes JavaScript fast enough to do this in the first place. In practice, if I type Node in my terminal right now, I get a live prompt where I can just run JavaScript right there. But more usefully, I'll write my server code in a file and run it with Node backend.js. A few things that you will use constantly, it's npm. Npm is a packet manager. So npm basically installs like pull-in libraries with a so you can do that by using double hyphen save, like for things your app needs to run. And when you use double hyphen save hyphen dev for tools, that tag is basically for the tools you only need while developing. And so Node defaults to an older module system called CommonJS. But in this course, we are using ES modules, like I said before, ESM. So you'll have to add the type colon module to your package.json or to your import. Or all your imports will throw an error by default. One more quality of life tool is NodeMon. So it watches your files and restarts the server every time you save. So you don't have to, kill the engine and rerun it by hand every time you make a change. Now, the real shift to wrap your head around is this. So, JavaScript is running in two places, the browser and the server. But some things only exist in one or the other. Next, Node on its own is fairly low level, but we have a framework, like a tiny framework that sits on top of this node, that is Express. And it is one of the most used libraries on the web because it makes building a server simple. The smallest possible server is basically the three lines,
that is like right in front of you. You export express, you create an app with a const app equal to express uh, round brackets, and you tell it to listen on a port, usually the process.env.port with 3000 as a fallback. That is it. You have your running server. That's very simple way of running your server. In our application, Express does two jobs. It serves the static front end we already built. It also exposes the routes, which are the endpoints that hands back the data. Now the second job is a piece that turns a project's static app, like our project one, whatever static app that we built, we convert that into project two, our real three-tier full stack application. So made of a client, node, Express server, and also that MongoDB database. Okay. So now we have both sides, the front end, which is HTML, CSS, and JavaScript, and the server, which is Node and Express. Before we build anything, two things tie those two sides together: how they actually talk to each other and the shape the system takes. So let me cover both quickly. Back in the intro, I said the client and the server talks over HTTP. Let me make that a little bit more concrete. Every request the browser sends carries a verb and action. There are four main ones: get to read something, post to create something, put to update, and delete to remove. And these four map exactly onto what we call the CRUD: create, read, update, delete. This is not a coincidence, it just matters for you directly because the project 2 requires full CRUD on one of your collections. So the address you send that verb to is a URL, and the URL has three parts: the scheme, HTTP or HTTPS, and then the host, which in development is just localhost, and then the port, and then the path to what you want, and optionally some parameters after question mark. So, one security point: the plain HTTP is readable. Anyone sitting on the same network can see the traffic. HTTP is the same protocol wrapped in TLS, encrypted with certificates, so a person in the middle cannot read it. This is what the padlock means. And in 2025 Chrome, just assume HTTPS, and I mean, like as of now, it just Chrome just assumes it's 20 I mean HTTPS, and any client can talk to your server in the same standard way. So now the shape, that is let's say, how do we put it now? Okay, project one was a two-tier architecture, like a client and a server, but the server was just a static file server. Now the browser asks for a resource and the server checks whether that file exists and hands it back, defaulting to index.html or returning a 404 if it is not there. The server is just basically dumb. It only serves file, and all of your JavaScript ran in the browser. So when we add Node and Express, the server gets, in, let's say, like beefier. It can run code and expose routes, not just return files. But notice this is still a two-tier, just a client and a smarter server. It only becomes three-tier when we add third piece, that is a database, which for us will be MongoDB. Now a root can query the database and return data. Client server database makes it a three-tier. This is how our project 2 was, and project 3 probably will keep the this exact backbone, and we might just swap our hand built front end with React. Now one last decision is baked into all of this. Our roots just return JSON in just data, and the front end JavaScript builds the HTML from it. This is what we call as a front side or client side rendering, and it is what we do. The alternative is the server side rendering, where the server builds the finished HTML and ship it whole. So that is the old way of doing things, and funnily enough, it is coming back around as a new React standard. Again, for project 2, though we render on the client. So now that we have a complete picture, how the client talks to the server, get, post, put, delete, and HTTP, what the system looks like, three tiers, and the rule that our routers return JSON for the front end to render. So let's start describing it, like actually build what this, server side is, like express routing wired all the way down to MongoDB. Now, okay, in the breadth 2, we name the backend node runs JavaScript on the server and Express in the framework on top. Now I actually want to build that server side and wire it all the way down to the MongoDB database. This is the part where I'm going to deep dive because it is where a static site becomes a full stack application. Yeah. So, yeah. I'm going to follow one endpoint, the one that loads our orders from the server all the way to the database and then back. Light analogy here, just once. Think of the server as a kitchen. Everything past this point is what happens inside this kitchen. Okay. Now, this is the smallest Express server. Now, a question I actually want to think about is the function I pass to app.listen, the one that logs server on, in what line am I calling it? And actual answer is I'm not. I'm not even calling it. I'm never calling it. I hand it to Express and Express calls it for me. The moment the server is ready, you are passing a function. We are not running it. So the idea is that it comes back everywhere in the stack. Next, we have to serve the front end we already built. Express does that with just one line. That is the app.use. Yeah. So let's say when I get okay. So over here, one thing I would like to highlight is the order matters. So the line that goes before your routes, that actually matters. The Express handles the request by checking things in the order you register them. First, it asks, is this a static file? Can I serve it like in index.html or the CSS? If yes, it serves it. Only if nothing matched does it fall through to your routes. So static first, routes after. A route is basically three things: a verb, and a handler. Now, here is the one that runs our orders. So we have this app.get API slash orders. So when a get request comes into API slash orders, we run this handler. The handler always gets two objects, the request and then the response. And notice that what I send back is rest.json, not HTML. This is the whole point. The professor calls these data endpoints because they hand back the data and not the pages. If I return finished HTML here, that would be server side rendering, and we are deliberately doing client side rendering here instead. The two conventions that matter is that first, the slash API prefix. Every data endpoint lives under this slash API, and that is not decoration, it is a collision avoidance. Remember, Express checks static files first. If I named a route slash orders and also had a file called orders, that would be like a fight. So, putting all the data under slash API guarantees that they never collide. Second, you do not leave all your routes piled into one file. You just modularize them with an Express router. The app.use slash API comma order routes, routers is what stitches the prefix on. So the router slash orders become slash API slash orders. Same pattern that the professor uses, and it's how every real Express app is organized. Now, the piece before people skip, the middleware, which is one of the most important sites. Middleware are the functions that every request passes through before it reaches your route. So it's more like the logging, authentication, parsing the request body, all of that. Here is one bit of an analogy. Uh, I will allow myself, like, okay, so the middleware is the host stand. Let's say, okay, middleware is like the host that stand at a restaurant. Every guest that pass the host before they ever reach the kitchen, the every host can see them, check a reservation, or turn them away. So same thing here. Every request passes through your middleware before it reaches a route, and technically you already use one. Express.static is a middleware. You register the middleware with the app.use, and just like before, the order you register it in is the order request flows through it. So the mental model for an Express app is a pipeline. A request comes in, flows through your middleware in order, and lands at the first route that matches. So the server can answer. Now, how does the front end actually ask? This is the Ajax part, and it is just JavaScript. So this entire code, it fetches an endpoint. It has to be an async function because uh, fetch returns a promise and we await it. We check rest.ok first and bail every on failure. I'm sorry, we bail early on failure. That is a clean pattern, and we handle the bad case and return. So so that the happy path is not entirely buried in the nesting. So here we await rest.json to pass the body and hand it to a render function that writes it into the DOM. So here is a full round trip, the thing that professor like draws at every time. You open a local host, Express serves the static index.html which loads on your JavaScript. It calls refresh orders, which fires a fetch to slash API slash orders. That request goes back to Express. It checks static, finds nothing, falls through to the route, runs the handler, and then sends the JSON back. The browser passes it, and then it renders it into the page, and then the page never reloads. This entire loop is what we call as Ajax. One thing to flag, right now the route is returning a hard-coded array. It is faked, which is exactly the problem MongoDB solves. Yes. So the database type we use MongoDB. It is a little different from SQL database on purpose. MongoDB does not store rows in rigid tables. It just stores document. A document looks almost exactly like a JavaScript object. It's like a JSON shaped. A group of documents is called a collection, which is roughly equivalent to a table. A database holds your collection. If the let's say if the server is your kitchen, the database is the walk-in storage room where the actual ingredients live. To use it, you need two things: the MongoDB server itself, which runs either locally or in the cloud on Atlas, and then the node driver, which is a library your code uses to talk to it. The professor runs the server locally with Docker, which is a tool that runs little isolated, I mean, it runs the little isolated machines inside your machine. Now he, like the professor, mapped it to a custom port to avoid collision, but the default is 27017. So there are three ways to connect. Uh, yeah, there are three ways to connect. You'll use all the three for different reasons. Mongosh, the command line shell, Compass, which is the graphical interface, great for browsing your data, and then the node driver, which is what the application actually uses. For data, the professor sees 1,000 fake records with a tool called Mockeru, exports them as JSON, and then imports them into the collection. So my project needs a collection with around like 1,000 records. So that's worth knowing. So yeah. Now the next step is the querying part. So there are two ways. One is the MQ, the Mongo query language. It's a very simple thing. You can find a query object and yeah. So you chain on sort limit a projection to choose which field comes back and skip. And so plus, so one more thing is that a limit plus skip together are exactly how you build pagination. Another way is the aggregation pipeline for heavier work. Your data flows through stages like dollar. We use dollar sign, by the way. We use dollar match to filter and dollar group to summarize, and the dollar sign is how you name these operators. You reach for this when a simple find is not enough, and the crude mapping closes a loop from the breadth section. Get becomes find, post becomes insert one, put becomes update one, delete becomes delete one. These four verbs are the four collection methods. Now, yeah, we make this fake endpoint real. We bring in the driver and replace the hard-coded array with an actual query, MongoDB query. This is the whole change. We connect once, grab the collection inside the route, we query it, find everything, turn the cursor into an array, and then send it as JSON. The endpoint that used to return a hard-coded list now returns whatever is actually in the database. Nothing else in the chain changes. The front end is still fetching the slash API slash orders. So yes. Now here is the complete picture for this real, like for real. The browser fires a fetch over HTTP, Express checks static, falls through to the route queries MongoDB through the driver, Mongo returns the documents, Express sends them back as JSON, the fronter renders them into the DOM, and the page never reloads. So this is a full three-tier application end to end, and now I'm going to build the spine of it. Like we are gonna build it live, the express route, the fetch, and the render, so that you can watch the whole thing actually run. So okay, let's go to a global picture. There are before we go any deeper, I just want to put everything we have covered into one picture because it's easy to lose the forest for the trees here. So WebDev splits into two halves. One on the left, we have the building blocks, which is the front end, HTML for structure, CSS for style, ES6, JavaScript for the interactivity. Everything that runs in the browser lives on the side. Now on the right, we have the web structure, the web architecture that is.
how the things whole thing is wired together. We start simple, that is a two-tier static site, just a browser and a file server. Then we leveled up to the three tiers full stack, a client, an Express server, and a MongoDB database. Here is the thing: every single concept we have touched is one bubble on this map. This deep dive we just did lives right here. So let's just go ahead and build it.